So in updating our lab design standard, it was a process. It took us about a year. The standard was to align with the operational parameters outlined in the Z9.5, but we have been working on energy conservation for quite a number of years on this campus, and so we brought in these stakeholders and we sat down at the table, and sometimes these particular groups, facilities engineering, energy management, and EHS, sometimes we compete. And there was a little bit of competition happening, and we needed a document that served all purposes. And it took quite a while, but actually there were only a few meetings, and then there was writing on the side. And we ended up with a document that we're very proud of, and it met needs that were not being met before. And we noticed that when we're working with outside firms like ME Engineering, they already know what our expectations are because we've been working with them for quite some time. But on smaller lab renovations, there are other groups, smaller engineering firms in the area that don't know those expectations. And so it's a waste of time and money when they don't know because our design standard doesn't tell them so. And so we're hoping, this just was published in January on our facility service website, that over time, and this is going to be something I'm looking at, when we have small engineering firms that submit plans, that they actually align with this standard. The process that we have now provides more flexibility in sizing the systems. I've said this a couple times. The mechanical requirements are inputted there, and the interactions between departments during a lab design process. We wanted a document that would bring all these stakeholders, that in writing would bring stakeholders in at certain times earlier than normal, because we would need information from them so that we could move along in the process. Some of the things that we've added in or changed, we didn't have some definitions. A lab scale work as defined by OSHA is not pilot scale. It's very different. And we have researchers that are moving into the pilot scale work because of their research, because of their grant work or whatever other work that they're doing. And we needed to define that this design standard, it only meets the need of lab scale work, of lab scale renovations and building renovations or new building construction, so that when we have a researcher that needs to move up to pilot scale, we need outside expertise, and that the cost is going to rise. We needed to define that. We have an active hood hibernation. It's a temporary decommissioning, but we have termed it hood hibernation. We have an active process for doing that. We wanted to define that within the design standard because what we've noticed is that in some labs we simply can't hibernate them. There's no general exhaust to be able to turn off the fume hood, or mechanically it's not possible. We needed to define lab vacancy, which if you're a newcomer, vacancy is not something that's widely known, so we wanted a place for that to land. That's basically where we have a lab that is unassigned and the ventilation is practically off, and that saves energy. We inputted the New York State Mechanical Code Section 510, which is something that I wanted. This is requirements concerning hazardous exhaust systems. We wanted to define what a fume hood, we wanted some definition for what a fume hood is supposed to be used for. There are certain things that we cannot emit. We have a campus where we do modeling to see where our emissions will go, but we needed to have the guidance of that. What we also did, and I thought this was really smart of our mechanical engineer when she did this, there are general requirements and definitions and so forth that are in our document, but the exhaust analysis was way at the end. We put that front and center at the beginning because you need to know what chemicals you're working with and what you're going to be exhausting, that some things are going to require specialized exhaust. The design standard encourages the laminar flow in the lab to improve the ventilation effectiveness. When you have casework and hoods and other equipment, freezers, growth chambers, etc., that are positioned in a way in the lab that blocks the airflow, those are going to end up being labs that are banded at 8 and 4 because they don't sweep the air through the room and out the exhaust points. So we wanted in writing that this is what we expect. We want casework to be located in such a way that there is this laminar flow. We've actually had outside firms that didn't understand what that was, and so they designed only to what the PI was asking for and what might have been already in the ceiling. And they didn't take this effectiveness in consideration, and so they submitted plans, and we had to go back. We had to send them back to the drawing board because it just wasn't going to work. And that's just a waste of time. The requirement for CFD modeling tied to the size of the project budget, this was kind of a sticking point. CFD modeling actually, we've done this ahead of energy conservation projects and some large building projects, but it's very informative for how you want to set up a lab, but it's also costly. And so our mechanical engineering section needed some definition for when this is done. You can't expect a $10,000 model to happen on a one-room renovation, but it is a reasonable expectation for projects that are in the millions because it informs us of how we want to design our labs and in a way that we, even experts, even those of us that understand ventilation effectiveness, may not be able to define very well. The standard also encourages the putting in hoods that will contain well at 80 feet per minute. I understand probably several people on the phone have fume hoods on their campus that go much lower. We would like to be able to commission standard fume hoods at 80 feet per minute. They're not all created equal, so we wanted someplace in writing to encourage that we get fume hoods that will meet those requirements so that when we commission, we can do so at 80 feet per minute. And then we put in terminology for the lower minimum air volumes for the fume hoods. What's in the Ansi standard as just some guidance is the 150 air exchanges. We didn't want that to be confused with the requirements of the standard. This is approximately 10 CFM per square foot. Basically what this means is we had several design details associated with the standard that we also made reference to on the document that were revised at the same time. We put the verbiage about the 150 ACH rates, which is probably going to be what we use all the time, in there so that if we had basically going to do that all the time unless we have to take a look at the expected use of the hood, and then we'll actually have a minimum airflow that's probably going to be higher, but for the most part we're going to lower the minimum volumes. We just needed some guidance and have it written down how we're going to go about doing that. Things that we're working on with the program, we need additional training for lab occupants. We have good training, but there's many ways of reaching these lab occupants, especially the students, because this is new stuff. This is tied to the Green Labs program. They are our next generation, and we want them to leave with the sustainability bug in their ear when they go out to work. we need to continually raise awareness to the lab occupants' role in the system. It's amazing how little lab folks understand what their ventilation is supposed to be doing for them. We want them to let us know when something doesn't smell right in their space. If we do go in and reduce and control band and reduce the airflow in the space, we want the lab folks to understand that they have a role to play if something doesn't seem right in their space anymore. Annual reporting of the results, scoring the lab banding efforts that is happening on a weekly basis. Also, a lab housekeeping score that's new. These are all in development because the program has been about for a couple of years, but it is comprehensive, and we're always looking for ways of making it better. The hood hibernation standard operating procedure, we have a university asset management database. This is the maximum database. The practices for hibernating the fume hoods, it's pretty robust, but we're writing a standard operating procedure so that this actually lives within this database because it makes it a system. And something that the Ansi Z10 says is that a system needs to be, well, it needs to be systematized. It can't be dependent on people. And the database, it has administrators, but when we have a system in place for a hood hibernation to happen, we don't want it to be just a bundle of emails that may or may not get to the right people or people miss because they get 100 emails every day. We want it to be part of the system that continues on when people take on different roles or leave the university. The other thing that is more of a training for myself, we'd like to see the high performance, low flow fume hoods come onto campus. I need better understanding of what the modified ASHRAE 110 testing is. There's other specifications out there for the hood performance criteria. I would like to have institutional design specifications for the designers to have, that when they go to choose a fume hood to put into some new construction or renovation, I don't have to worry that they went to the specific manufacturers that they are allowed. I want the hoods that they choose to perform to certain criteria. This way, we're keeping up with the technology that is coming out. I'm sure many of you have noticed over the last 5 years, there's more hoods. There's a lot of competition for fume hoods that operate at very low volumes. And so the performance criteria, I think, is something that I would like to see for our purposes, whether the ASHRAE 110 actually gets revised or not. But I would like it to align with some of the other design specs that are out there. Some are more understandable than others. So this is something that I would like to touch on by the end of the year, and that may include some folks that are on the phone right now that come on campus and help me through that process. So that's it, and hopefully everybody